Welcome back. I hope you enjoyed the first two labs so far. For lab 3, we're going to do Introduction to Container Orchestration. But first, let's take a step back and remember some of the appeals of using containers in the first place. We avoid the works on my machine problem. It's very lightweight and fast compared to virtual machines. You get much better resource utilization, get high density on your infrastructure, so you save money. And there's a lot of ecosystem and tooling. But the problem with these benefits is that it's only about half of the problem. Because when you start to use Docker in production, you start to come across a whole nother set of problems. How to schedule your applications across the cluster, scaling your applications, handling service discovery, rolling updates, high availability, fault tolerance, and advanced deployments, graduated A/B deployments. And of course, these problems aren't really specific to containers. These problems have to deal with any type of distributed application. But what I wonder is, since we're using containers, is there a solution or a project that can take advantage of our new containers abstraction? And the answer is there is, and that's called container orchestration. So the responsibilities of a container orchestrator is to do cluster management, scheduling your applications, service discovery, pretty much everything that I've listed in the previous slide. Container orchestration solutions generally work with by declaring your desired state with a cycle for active reconciliation. So the way this works is you tell your orchestration system, this is what you want. So I want this application with 5 instances running. And then the orchestrator will go through the trouble of looping and then once in a while checking to make sure that what you've declared to be what you want matches what is the actual state. So in terms of the ecosystem, the container orchestration layer rests on top of the containers interface. And there's a number of container orchestration solutions out there. So the open source projects, there's Docker Swarm, Kubernetes, and Apache Mesos Marathon. These are all open source projects, and there's a few out there as well that I'm not listing. But for each of these open source projects that do container orchestration, you'll find the cloud providers with a number of hosted solutions around these projects. So, for example, IBM has something called the IBM Cloud Container Service, which is hosted Kubernetes plus some added value such as IBM Cloud Integrations. Amazon has AWS ECS. Google has Google Container Engine. Microsoft has Azure Containers, and so on. So after you learn about container orchestration and get to be getting close to using this within your organization, you're going to want to look at some of these products to see which one could fit for your use cases. So for the lab today, we're just going to get a brief introduction to container orchestration, and we're going to use Docker Swarm with that. Because Docker Swarm and using playwithdocker.com is the easiest way to set up a 3-cluster or a 3-node cluster with container orchestration installed on it. So we'll use Docker Swarm to schedule applications and then scale them up. We'll expose our applications publicly, and then we'll see the effects of Docker Swarm built-in routing mesh and load balancing. You can update your application with a rolling update, so 0 downtime deployments, and demonstrating node failures. So taking down a node that has running containers and then being able to see those containers, or be able to see the container orchestration system actively reschedule those containers on other nodes without you telling it to. And then after you complete this lab, again, I highly encourage you to explore some of the other tools out there, such as the IBM Cloud Container Service.